Okay, greetings. Thanks very much for including me in this salvage series. I'm going to give you a couple of case studies from our research in Colorado. As you can see from the slide, I've got one set of case studies regarding our lodgepole pine work and some with some preliminary work we're getting started on Engelmann spruce. And I've got a whole lot of collaborators I should thank. Some of them listed there, managers that I've got listed at the end. So the first thing I'm going to do is turn my photo off. I don't think you guys need to see that. And we'll get started. Okay, so a few years ago I had the opportunity to be involved in a synthesis of salvage research with some folks from international researchers, some from Europe, Australia, a lot of people from the US, and surveyed a number of different projects and a couple of just sort of major take-homes I thought I would start out with. Probably no surprise to anybody in this group, the majority of the work that's been done in salvage research has included, has focused on wildfires. There's been a bit and a growing amount on insect outbreaks, and most of what I'll present today has to do with that, and then some wind throw. Interestingly, I suppose the bulk of the work has focused on tree regeneration, vegetation cover, fuels. They call it dead wood here, and with less focus on things like soils and water, carbon, or various different ecosystem services. And I think that makes a lot of sense. The focus of the work primarily is to reduce fire and fuels, and often to regenerate stands. So that's no surprise. And importantly, I don't really think that these various components can be pulled apart and from a multidisciplinary perspective, as most of this management is done. There are kind of both parts to a number of attributes in every study. So anyway, with that, I'll get started on some of our work in Colorado. So as many of you are aware who work in the Southern Rockies or the Western U.S., we've had a large beetle outbreak. It started in the early 2000s. You can see outbreak acreage in Colorado. The onset was in 2003, and then the peak, depending on where you were, is 2004 to 7 or something like that. I have 7 to 10 actually, but it was sort of bracketed this period here, and it went through areas. You can see in the upper right-hand corner a photo from the Fraser Experimental Forest, where almost all of the overstory of that drainage was beetle, and almost all of it died. In some of these areas, we had over 90%, especially in areas that were salvaged. So these are 4 project areas in the northern part of Colorado. That's what this map shows. The red are beetle acreage along the Colorado-Wyoming border over about a decade, and these 4 areas are sort of bracketing that zone on both federal and state land, and with lodgepole pine mortality shown here, above 70% in most cases, and in 90 in some. Okay, so the beetle outbreak kind of brought about a change in management. The change in forest health was a real severe change in an area where timber harvesting had been kind of on the decline for several decades, and there was a big push to see a lot of management happening quickly. This shows the acreage that was harvested on the Sulphur Ranger District, which is part of the Arapahoe-Roosevelt, and one of the sort of epicenters of the beetle outbreak near Winter Park. You can see the decline in harvesting as mills were closed throughout Colorado in the 70s and 80s, and then a big rebound during the beetle outbreak, most of which were clear cuts. A lot of that area is now been developed. There's a big recreation industry and a lot of second homes, so people were very concerned, and there was a lot of vocal interest in harvesting getting started. The land management agencies in this area, the Forest Service specifically manage under multi-resource, multidisciplinary priorities, and so we set up some of our salvage research to try to compare a variety of different objectives. So, of course, we had a do nothing uncut situation. We also had the primary objective for many of these projects was fuels reduction, crown fuel reduction. So that was one of the priorities. Tree regeneration was another one. So we had a treatment that included post-harvest site prep and mechanical scarification to try to bring on additional tree regeneration, and also a more watershed-focused water yield where material was left on the ground in sort of a biomass retention perspective. These treatments are certainly not exclusive. You could think of them as biomass removal, biomass retention, as well as fuels reduction and water yield. So they kind of hit various objectives. We had kind of two different study focuses. One that was a simple cut leave at an operational scale. We had 24 different sites across those project areas I showed before, where we compared, we had plots and transects in uncut stands, and we compared them after harvesting. And then we had an experimental component where we tried to test the various treatments I mentioned earlier. So a lob and scatter or boiler removal, a whole tree harvest or fuel reduction, and a scarification, which focused on the tree regeneration aspect to try to reduce competition. So some of our findings to start out, kind of a Lodgepole 101. What we started by actually looking at post-harvest stalking surveys from the Arapahoe Roosevelt forest, and looked at some historic pre-outbreak stalking surveys to get an idea of what kind of regeneration there would be within the first several years, and compared them with the outbreak years, just to try to get some quick and dirty idea of whether or not there would be concerns with stalking. Lodgepole pine, we all know it tends to be a weed, and in this case it's showing its true colors. It regenerated very well, and 90% of the salvaged areas had at least as much as they did in the pre-outbreak green phase. So that was kind of a good place to start. Similarly, after treatments that we installed in the harvested areas that were harvested in 2008 and 9, we showed that there were big increases in new pine recruits, 5 times more than in the uncut stands, and also a big increase in aspen sprouting. The red line here and the dotted line here are both U.S. Forest Service stalking thresholds, 150 trees per acre or 370 trees per hectare, below which there's some concern about the regeneration, whether there might need to be planting. You can see that we have surpassed that in most cases. The one notable exception in these areas, which again is not a big surprise, the shade tolerant fir did not do well in the harvested areas. So if we take that sort of initial stalking densities and grow stands forward, we see some interesting patterns. So we have basal area and stand density, trees per hectare, on these two rows, and we can see that lodgepole pine is going to return basically back to where it started from within about 100 years. This is looking over a 100-year time frame, and in that century of growth, we're back to the same basal area and trees per hectare that we were initially, which is no surprise. The trees were about 100 years old when the beetles hit them, and in another 100 years we expect them to be back there based on typical growth models. An interesting fact, though, is that we see an increase in in the fir in our uncut stands. And so over time, in uncut areas, we actually see what will be sort of a change in species composition in some of these stands, and that's creates conditions that might alter the way fires burn, the fuel profiles and ladder fuels. That's sort of a bit of a cause for concern, and it's also not a timber species that people are terribly interested in. Though we don't see much of this kind of stand type on the landscape now, that has been confirmed from earlier beetle outbreaks by some of our colleagues that looked at outbreaks that happened in the late 70s and early 80s. If we think about fuels, again, these are the things that are easy to measure and are the objectives of the salvage studies to begin with. Not surprisingly, in our cut stands, we see increases in surface fuels, which is typical of logged areas, and we see 3 to 4 times the levels of activity fuels, and a significant increase that will probably could have an effect on potential flame lengths if a fire got into those areas. However, the real comparison is looking out at what happens to the uncut stands once those trees come down, and we see here, I mean, basically turning the standing tree density into fuels, and we end up with nearly double the amount of fuels on the ground once those trees come down. So that's kind of the comparison that's pretty critical. The objectives were to remove those coarse fuels from the sites to reduce fire effects and provide greater access to firefighters to the ground. Well, I wanted to put in a slide about a recent study that we've done regarding the idea of snags and the loss of when those would come down. Earlier studies in lower elevations indicated that within the first decade or 15 years, most of the dead standing beetle kill trees would be on the ground. And based on our work at the Fraser Experimental Forest, that's not what we found at all. In fact, in the first decade, we found that only about 17% of all of the beetle kill trees had fallen, which was pretty surprising to us. And if we look at those relationships and plot them out over time, we expect that there actually may be another decade or two before we see all that material down. The half-life of those dead trees is probably nearly 20 years, 17 years in fact. So we expect to see dead standing trees for a while. Now, as we published this paper, we in 2020 in Colorado, we had a big wind year, which tried to prove us wrong. We saw a lot of patches of both beetle kill and green trees coming down, such as in the picture here. A lot of what you see there is actually from green trees that have come down, but we are seeing in patches large amounts of the lodgepole pine coming down. So it seems like as things go along, it's not going to be a nice gradual trend. It might be patchy in places. Regardless, salvage logging continues and much longer than what was originally expected. So the fuel picture, just a little bit more on that, comparing the uncut and the cut trees. Because of the increased fir that we project in those uncut stands, we actually think there'll be a greater development or faster development of crown bulk density and more rapid return to active crown fire conditions. So higher flame lengths, and more risk of crown fire in those uncut stands, after about 50 years. For the first couple decades, things of course will be quite a bit lower. These are the red dots, and those red lines show what a green stand would be. In other words, an untreated live stand, to give a point of reference. Okay. Great. So to move on to some ecosystem attributes, looking at soil disturbance and soil carbon and nitrogen. This is now looking at our experimental scale, so looking at the bowl-only, whole tree, and scarified plots. And what we can see here is that both the bowl-only and the whole tree had similar amounts of soil disturbance using typical visual indicators of soil disturbance, and this moderate and light disturbance, meaning that you could tell that it had been tracking on the ground but no displacement. Compare that with the scarified treatment, where intentionally we went in to try to move things around to create a mineral seed bed, and we see 40% displaced O horizon by description. So that was an intentional thing. But you can see in most cases it's fairly low. But the point that I wanted to make is that soil organic matter, both soil total carbon and nitrogen, actually increased in our harvested areas compared to our uncut areas. So the black dots are uncut. You see them here. This is carbon. This is nitrogen. You can see that those are lower, and you can see that as you move to the right here, especially in the scarified plots, the ones that had the greatest amount of disturbance, we see the highest increase. The patterns I'm showing is the increase in carbon and nitrogen with the fine fraction in soil, which is a well understood relationship. That's what's holding on to that carbon and nitrogen. So thinking about some other soil conditions that are impacting post-salvage regeneration. The harvesting increased the total carbon and nitrogen, as I just showed. Also, soil moisture, the gravimetric soil moisture shown here across a couple different seasons in our different treatments. So uncut, bowl-only, or lop and scatter, whole tree, and scarified. Specifically, the bowl-only treatment had the biggest influence on soil moisture, especially in the spring. And we know that adding slash or leaving slash on the ground catches more snow and can contribute to increased soil moisture. So that's one of the reasons we were actually interested in that treatment. And you can see that pattern staying as the soils dried out over the season, although it became a little bit more muted. There are also higher amounts of plant available nitrogen, both ammonium and nitrate, the forms that plants take up, and then the production or nitrification, which is the formation of nitrate, that was higher in the bowl-only treatment. So there were some advantages in that treatment. And scarification, I already showed you, where there was higher disturbance, had the highest amounts of total carbon and nitrogen. Okay, so back to trees, how do those things kind of translate, and what do we see with the tree regeneration? So we saw that that comparing our various sizes, so new seedlings and sprouts, advanced regeneration less than a meter tall, and advanced regeneration that was more than a meter tall in our various treatments. So the white is uncut, bowl-only, whole tree, and scarified in this way, and looking at pine, fir, spruce, and aspen. And we see good pine regeneration across the treatments compared to the uncut. That's similar to what we showed in our operational scale studies. Fir generally declined in the harvested areas, although there were some cases when it didn't do so poorly. Aspen did quite well, especially in the scarified treatment, where and we know from previous studies that have been done that suckering responds to a little bit of soil disturbance. So that was kind of the response that we were seeing here. It's noteworthy that scarification is often done in places where there's a lot of competition from grasses or sedge, and we actually saw no response in sedge cover to the scarification treatment. In terms of understory stuff, the biggest factor we saw was a decline in understory cover in the cut versus the uncut treatments, and that was largely due to the loss of vaccinium or whortleberry, which is a small shrub that's the most common understory plant in these systems, but that's very susceptible both to light and soil disturbance. So it sort of vanished from the sites. Okay, so in addition to the natural regeneration, we planted pine seedlings and looked at tree growth. So across uniform size material at the start, we looked at how these things responded to the various factors. Again, you can see the treatments, the uncut trees we planted into the dead forest. You can see they didn't do so hot. The best growth was in the bole only treatment, or the lop and scatter treatment, with scarification coming in a close second, and whole tree about 30% lower than the bole only at the end of this particular study. Again, I showed you some of the soil resources, moisture, and nutrients that might have explained the difference between these treatments. Okay, so moving in sort of a different direction, the beetle outbreak also created opportunities to think about things in new ways. And one of them was what happens if the forest that you're saving in a riparian buffer, if that's populated by dead trees. There are concerns that you might actually be leaving your precious aquatic resources susceptible to some damage if those forests burn. There's also some question about whether or not those dead trees are actually doing anything to protect water quality. So we put in a study to compare intact dead buffers and buffers that we had managed to remove those dead trees. So we compared uncut hillsides, areas with an intact dead buffer, and areas with a removed buffer. We did this with 5 replicates on the Sulphur Ranger District of the Arapahoe Roosevelt. The treated areas were 500 meters long, and we had 5 replicates of those. And mostly we looked at soil nitrogen and leaching, the leaching of nitrates specifically, that tends to make it into streams and influence stream water quality. So the one figure I have to show you from this was from a paper in 2018. Shows on the left, we see what we would expect. Comparing cut and uncut, we see an increase in the amount of nitrate in leachate. This is the soil solution below the rooting zone. We see that there's a 2 to 3 fold increase in that nitrate leaching, and an increase in DOC or carbon as well. Total nitrogen went up as well. But the important point for our study was to compare what was going on down in the riparian zone. And so we see the uncut hill slopes. That means they had an intact buffer and an intact upland, cut upslope and with a buffer intact, and then the buffer removed here. And what we can see is that cutting the forest above it had an effect down in the riparian zone. So even though there was no cutting down there, we could see that leachate is making it down into these riparian areas. So that's important to see. It's basically the downslope effect of what we see on the left graph here. So we see an increase, and then more importantly, we see that there was a much larger 4-fold increase in the nitrate that's being leached in areas where the buffer has been removed. So this gives us some confidence that leaving buffers has a positive effect. But the flip side of that is that these numbers, though they show statistical significance, they're not very high. So nitrate numbers of less than of a half of parts per million are not going to be something that would be a large downstream concern. But this is evidence that the riparian buffers are working, and that also that if a buffer is removed carefully, like we did in these studies, where there weren't vehicles that were driving around in the riparian areas, we might be able to live with these level of changes without having a significant effect on aquatic biota or downstream water quality. Okay, so moving a little bit more broadly, I put on the first slide, I don't think I mentioned it, that most of the studies that were done in the original synthesis only looked at one disturbance, and that's for obvious reasons. It's hard to actually think about multiples doing salvage logging after various different combinations of disturbances. But here in Colorado and elsewhere in the West, we're becoming more and more aware that these disturbances are sort of stacking up on top of each other. And in Colorado, the particular combination is fires after bark beetle. And so in the first decade following the beetle outbreak, we had about 150,000 acres of what we call gray phase fires, so fires that burned in stands that had been dead for a long time from the beetle outbreak. But in 2020, last year, we had a huge blow up of those fires, and most of the big burns that you probably heard about in Colorado, the record-breaking fires, all of them were in gray phase forests to some extent, some of them very extensively, and that the relevance of that I've got to share with you from a couple of case studies. The first one is the Churches Park fire, which was near the Fraser Experimental Forest. The fire occurred in 2010, and interestingly, it occurred in an area that had recently been salvage logged from the beetles. So in other words, there were bugs, salvage, and then fire. And what we've got here is tree regeneration for lodgepole, spruce fir, subalpine fir, and quaking aspen, comparing uncut stands, salvage logged, burned areas, and burned in cuts. And the take-homes are fairly straightforward. After 4 years, we saw no regeneration of lodgepole pine or subalpine fir regeneration. We saw good regeneration of the lodgepole following the cutting, which we would have expected. We saw a big increase in fir after the beetle, which we've seen and I showed you earlier. Aspen kind of worked across all conditions sort of equally well. The lack of lodgepole regeneration was surprising because these are serotinous cones, but in these stands, but fire severity was severe and cone consumption was very high. So the explanation was that loss of cones that explained that loss of the low lodgepole recovery. In another case study nearby, this is along our sites along the Colorado-Wyoming border in fires in 2016 and 2018, we also saw fairly low regeneration. And we looked specifically at serotiny, and what I wanted to point out was usually in studies, especially studies that have been done in the Northern Rockies or in the greater Yellowstone area, if you have 10% or more serotiny in a stand, that's usually enough to fully regenerate the stand. But in our case, we weren't seeing any regeneration at all until we had well over 50% serotiny in the stands. That was fairly surprising to us and made us start to think a little bit more about the serotiny question. Serotiny, as you know, is sort of a kind of a fail-safe source of forest resilience following fire. Maybe. And the situation that we've gotten into now, we've got stands that have been dead for well over 15 years, and then fires have moved through those. And so, for example, these are some data that we collected in stands around the fires that happened last summer in Colorado and Wyoming, Cameron Peak, East Troublesome, Williams Fork, and the Mullen fires. We looked at 2 stands in each of those and looked at seed germination by age. So we looked at various ages of cones, and what we found was a bit surprising. Overall, we only found 34% germination of the seeds that we collected from those cones, and that compares with about 90% germination, which we would expect from serotinous cones on green trees. So trees that had been burned when they were green, we would expect 3 times more germination and then 3 times more germinants per cone. A large number of these cones had no seeds in them whatsoever. They were also very hard to open, and at this point, after being on the trees for 15 years, they're they're sort of functioning like fossilized cones, and the takeaway is that there's probably some limitation or decline in seed availability or seed limitation in these lodgepole pine stands, and that has relevance to our salvage logging operations. Of course, lodgepole pine is an abundant cedar, and this is not a huge concern, except in cases where we're thinking about lodgepole pine possibly helping out in places where there's spruce fir that may also not be doing well, or places where we expect, you know, that kind of aggressive colonizer to sort of take up some of the slack. Okay, so some of the take homes from this from the salvage studies. We see that tree regeneration is abundant in the uncut stands, and that we have good growth in the overstory and the understory that's responding to the loss of lodgepole, and that harvesting creates alternative slash management creates various conditions. We found low leaching in dead riparian buffers, and that they appear to be effective. And that perhaps novel, careful riparian management may help achieve both fuel reduction and watershed protection goals. And then finally, these overlapping disturbances may create some new challenges for recovery and salvage operations. Then just as a final take home, since this is recorded and you can't leave, I'm going to just throw this in. This is mostly an advertisement for an upcoming project. This is work that's going on down on the Pike San Isabel in spruce, where there's dead spruce and dead subalpine fir. We're testing a novel tethered logging cut to length system. This is the first experiment of this in Colorado. This is work that's been done in conjunction with Alex Rudney and folks from Arwick, Andy Lurch from the Arkansas River Coalition, who are overseeing this work, and Miller Logging out of Oregon, who are helping out, who are doing the work. These areas are on 40 to 60% slopes. And the question that our management colleagues have for us is, what are the sorts of water quality or erosion concerns, and how might those be mitigated? So we've put in an erosion study with Lee McDonald, a retiree from CSU who has decades of experience in erosion studies in logged areas. We compared bare areas, trails that had low slash cover, and areas that had high slash cover. The typical system is to cover the entire trail network with slash, but considering how much of these stands were dead, there was actually quite a limitation in the amount of slash. So just a tiny bit of data, and hopefully an advertisement to stay tuned. We have seen a bit of erosion in some of our sites, and what we saw was not unexpected. We saw virtually none on the uncut areas, a slight increase in where we had the fully slashed areas, and the most on the bare trail areas. For comparison, areas that have been salvage logged following wildfire can have higher levels than this, and this was a one-time maximum number. So at this point, we're not terribly concerned. We saw rilling. Our longest rill was almost 60 meters long. They all started in bare areas, and this was all year one data. So we suspect that following that next year, when we go back, we'll see kind of a decline. That would be our expectation. And then to leave you with a sort of a thought on the land use context, our Monarch Pass project had one very large storm this summer. It was a ½ inch of rain in 15 minutes, or 2 inch an hour. event, and the Cameron Peak Fire had a similar event. Cameron Peak Fire, which was outside of Fort Collins, had about a half an inch in 14 minutes, and the differences are a bit of rilling and erosion in silt fences at Monarch Pass, and here we had a major debris flow, homes lost, and 4 fatalities. So some of these comparisons, I think, are sort of relevant to keep in mind when we think about why we're salvage logging and what kinds of ecosystem consequences we might be able to put up with. And with that, thank you very much. I have many management partners to appreciate and acknowledge, and a number of funders. So with that, hopefully we'll have a chance to talk during the roundtable next week. Thank you.